Hi there, and welcome back to this series of videos that we're talking about the not so simple flight mechanics and aerodynamics of Ironman. So we already introduced the problem what we're doing in the previous video. So now let's talk about the geometry. Now we know the geometry is always the starting point. So this is the geometry we have, and just want to give credit to the author of the geometries. Here you have the link. I guess you in internet you can find many geometries. This was the one I liked the most. It was free, okay? And just to mention that you can get the geometry, you have the link there. So it's shared using GradCap tool, okay? So my credits to the original author. It's a free geometry. So you download here the geometry. The original format is parasolic, okay? And just to mention something about the geometry here, I'm using Space Cleans to work with the geometry, where you can use any CAD software. Okay, by the way, I recommend to use Fusion 3D from Autodesk, okay, and you can get a free license for personal use. And later we're going to see why I recommend this one. It's another option to Space Cleans, okay, it's up to you, and there are many tools, but you need to use a decent CAD tool or solid modeling tool. So this is what we have, and talk about a little bit what we're getting in, because the starting point of every simulation, it is the geometry, okay? And then you have the mesh and so on. So whatever you get in the geometry, you're going to have in your mesh. So if your geometry is dirty and complex like in this one, that might be a problem, okay? So that is the first issue that we need to solve. So here you can see that we have more than 1,000 components, okay, intersecting, overlapping components. Somewhere here we have surfaces are really bad now when we're doing meshing, okay, and small details that we don't want to take into account, okay? So it's very nice to look at the geometry as a solid modeling, but for the sculpt, the goal of doing the 3D simulation in CFD, it's not very nice having all these components. So the first step is that we need to take, okay, an approach on how to deal with that problem. So basically what we're doing is that we're taking our geometry, all those features, but we're using a method that is called thin wrap, or thin wrap. Okay, so basically what we do is that a surface mesh in this complete geometry, and we aim at capturing the main features, and then we decide what is the level of resolution that we have. So now that we have this surface mesh, okay, can be any format, so probably you're already familiar with the STL format. This will be our input for our meshing tool, okay? So these are our steps, our complex and dirty geometry. So this is a dirty, okay, complex geometry. We use a fault tolerant method, meaning that we're going to use this thin wrap, okay, to cover everything. So see that here we don't have any gaps, anything. Maybe there's an imperfection in the mesh. So later we're going to see how we can solve that. We need just to add some smoothing and sculpting into that. And after you have this, you can do whatever you want. So here you have an example that we generated the mesh, and see that how well we managed to capture most of those features. So here in Space Cleans, so basically how this tool works in Space Cleans or any other decent CAD tool, basically you select everything. So let me go here, and somewhere you should have a tool to deal with facet surface triangulation. So here you see we have this thin wrap method. You click there, and now in this case it's going to give a few options. So this is the gap size, the dimension of that triangulation. Just choose there. So in this case I know well by geometry, I know that 20 millimeters is a good value. So 20 millimeters will be what you see in these slides there, okay? You can put it smaller and smaller, and that file, you're going to capture more details, and let me show you here. Okay, so see that this is 10 millimeters, 5 millimeters, and 2 millimeters. So see that you start to capture more details, but you have a much finer surface triangulation. And internally, these files, when you save these files in a STL file, those STLs can become as large as 1 giga, okay? So not only will be the problem that, okay, you have too many details, and even if you manage to capture everything and have something very smooth, you have a 1 giga STL file, so that can slow down everything the meshing process. So be careful about that. So for our proposals, I'm going to work with this one, the 10 millimeters that managed to capture everything nicely. And just to show you here that Also, the choice, the value that you choose. So you're choosing a large value of gap size, see that it's closing those holes while capturing the most relevant features. Okay, so in this case, 5 millimeters, you start to see all these holes and so on. That might be not very important to you. Okay, so coming back here, so basically, depending on the tool, but you will need to define this gap size. Then you have preserved features. So this is very important. Okay, many cases you have important features, namely, and we're bringing here what you see continuously in the snappy X mesh, feature edges. So if you have feature edges and so on, this one will try to preserve all those sharp angles, and then you can add some refinements. So you see, you select this one and you have here the angle threshold, and here a secondary size. So this is the largest and smallest one, and according to gaps and curvature we do the work. So let me just show you here what happens. Let me put here 20 millimeters. Okay, and preserve. I don't want to preserve in the first test, and click here. So this also can be a time-consuming operation. In this case, it's not that time-consuming, maybe 1 minute, no more than 2 minutes, but the one where I go 2 millimeters or even 1 millimeter, it is very time-consuming, about 2 hours. And by the way, you need a lot of memory. Okay, not only RAM memory, also your video card memory, because this is a very expensive operation. So let's wait a little bit here to see what we get with 20 millimeters and not capturing, okay, the features. So let's wait a little bit. Okay, so we have something, and see that 20 millimeters, okay, and this is what we have. Okay, so let me go here that I have the geometry there. Okay, so see that we get something that we managed to capture the most relevant features, or not the most relevant, but we know this is have a human shape. Okay, we don't know what it is. Okay, a little bit strange here, shoulders, head, but we capture that. So this is a very nice clean geometry, but we didn't capture all the most relevant details. So if you want to capture more details, and let me go here and see, put it here, and this, let me move here. So here we have 20 millimeters and no feature. So now let's do the same. Okay, let me do an undo here. Okay, we have everything, and let me enable preserve features. Okay, so probably will be a little bit longer, the computation. Probably it's going to work, let's see. I'm here doing off script. Okay, I didn't work in this geometry. Let's see what happens. Okay, we're back. We have a solution. Okay, so let me put it there, and let me copy this one. So we already see that there are some differences here. It was also more time consuming. Okay, took a little bit more time to get this one, and let me move this one also. So, and this one here. Put it there. So we have our iterations here. So let me put this one will be 20 millimeters, no features. Okay, and then we go here, 20 millimeters, features, and see that we already see the difference. That feature try to capture those sharp angles, better resolve. Okay, but in the way of doing so, it might add some other problems. You start to see now that those angles here, probably your mesh is going to have quality problems. So this is up to you. This is part of the assumptions that later we're going to discuss what is the problem, what we need to do, and what we can neglect, or what hypothesis can we make. So this will be here the 2 millimeters with features. Then we go 5 millimeters. features, and the one that we're going to use 10 millimeters features. Maybe I will also do the 10 millimeters no features. I will put it there next to it because it might smooth some scenes here, so it might give you better results. So this is what we have. This is where our starting point here from the geometry, which is very complex dirty geometry. We managed to simplify everything using the shrink wrap method. Do not waste time trying to use the actual CFD mesh here. It will be too time consuming. I'm not saying that you are not going to do it, but it will be too time consuming because you need to have very small element size. And by the way, as you use Snappy X mesh tool with OpenFOAM, that is really difficult. Okay, so this is it. Okay, the geometry, I will share everything now in the description. You will have a link, okay, where you can get the geometry. So I will share the document, the space clearance document, also the original files now. Here the original Parasolid file, so you can download everything and you can also contribute, and let's see if we can manage to get a good solution. So talking about the software that you can use, so I was using Space Clearance, but also I recommend you Fusion 360. Okay, it's a really good tool, so and free, which probably is more important for many users. Another tool also that I would like to use, or I'm already using, is this Autodesk Max Measure. This tool, many of the capabilities that comes with this one are already included in Fusion 3D. But the idea of this one is to do smoothing of this surface triangulation, but also sculpting. Okay, one of my goals also is just to change the shape, okay, and put it in different positions, like when he's flying, when he's hovering, and so on. Also move the arms and so on. So that can be done using that mesh mixer, but also I can do that one at the level. Let me go here back to the CAD. I have the CAD, I have all the components. Okay, so I can select some components there and I can rotate it and so on. So as you recall the movies, you probably have seen that the hands are a little bit rotated when he is flying, or kind of generating some thrust and trying to keep everything stabilized. So here, for instance, just see, let's see what we can do. You can put it there. In my case, I will be interested in rotating, so we can do stuff like this. So this is the idea that we have there, our geometry, but I think it is much better to work at the level of the mesh. So this is why I'm looking for a better solution when it comes to sculpting that, and I think Mesh Mixer is a very good one. I can do it also in a Space Clearance because I have access to those tools, but I already tested Mesh Mixer is a very good tool. So this is it now, the introduction of the geometry. So this is our next, our first step. Then we're going to move to meshing and keep going, but in the next video we're going to address something very important as well, the problem formulation. Okay, so CFD is not only about these pretty colors, we need to understand our physics. So we're going to discuss a little bit what we want to do, but also what simplifications what can we do, okay, and what we're expecting, but also the path that we need to take to solve our problem. Okay, so we're going to discuss that, and small issues such as, for instance, I have the geometry here, and let's say measure the height. Okay, you go here to here and see that the height is 2 meters, 2.2 meters. Okay, a little bit taller. This is not the typical Tony Stark, so these are small things that if you don't take into account, you are simulating something that do not correspond to the actual height of Tony Stark. It's a fictional character that we don't know, but these are small details that we need to take into account. So to the time of when doing the simulation, I know that this needs to be scaled down a little bit. What height we're aiming, probably 1.8, who knows? And since that the weight, okay, the weight of Tony Stark with the armor and with no armor, and the position of CG. Okay, so these are small things that needs to be discussed. So I guess I addressed everything related to the geometry, the origins of this geometry. So we took it from here. So there are many geometries that you can find in the internet, and then we apply the shrink wrap, and this is it. So in the description, you're going to find the link where to download this, and well, this is all for the geometry. So thanks for your attention and see you next time. Bye.